G-C.A.3 Worksheet 2 is about the constructing of the Incenter, or in other words, the Incircle, and the Circumcircle, and the Circumcenter. Whew! Say that 10 times fast. Now, I'm going to just do them by hand first, and then we'll run over and do a little technology to show you kind of the up close. Okay? And so let me just talk about first the idea of the circumcircle. Now, it is made by creating the perpendicular bisectors. So what ends up happening is you find the midpoint of a side and you create that perpendicular bisector. Now that line, anywhere along it, is equidistant to A and B. Every point on it is the same distance to A as it is to B. Then you can pick another, and so we pick over here and find the midpoint and do its perpendicular bisector. Now every point along that perpendicular bisector is the same distance to A as it is to C. Now this is cool because this location is the same distance to C and A, and it's also the same distance as A and B. So therefore it's the same distance to A, B, and C. And if you pull out your compass or your technology, and this is a poor diagram, but you're going to find it's going to go through all of those. Bingo. Now, it is possible for this guy to be in the interior. Sometimes, if you do the work, it is also possible when you do your perpendicular lines and you find your perpendicular bisector, it is possible to exist outside. All that means is that your circle, and this is going to be harder for me to draw, but will look kind of like this, is kind of what it will look like. Be kind, I was just going quickly. Now, the Incenter, or the Incircle, is made up of angle bisectors. So if you perform the angle bisector here, everybody along that line is the same distance to DE as to DF. If you were to do another angle and split it by its angle bisector, you will meet here. Now, you know what, I didn't mention here, but if I did the third perpendicular bisector, it actually goes through that point. It's a concurrent point of 3 different lines. So cool. The truth is, that would also happen here, is if I did this, I would also go through that exact same point. And in this case, that point isn't equidistant to A, B, and C, or to the vertices. It's equidistant to the sides of the triangle. So what's cool about that, and this is a tough, whoa, not too bad, you're going to get basically some times where you'll get a circle, if you want to call that a circle, that will touch all 3 sides exactly once each. Now this is cool. We better get to the technology to get to the specifics. But what I'm trying to get at here is to teach you how knowing what a perpendicular bisector does and is, and what an angle bisector does and is, then it'll help you to understand why these things work. Okay, let's take a look at it. All right, I'd like to demonstrate how you do the construction of this. Now, I'm going to do it with the tech tools. You'll do it with probably the compass and the ruler. Basically, you're going to create a perpendicular bisector from each of the sides of the triangle. So what I'm going to do is create an arc from both sides. And the way I do that is basically, you know, your standard construction of midpoint. And so now I'm going to go get the line tool and say I'd like it from there to there. And what that allows for is that perpendicular bisector. And then what I'm going to do is I'm going to run over and do another perpendicular bisector. And I can, you know, pick whatever length I want. Let's pick something like this maybe. And I'm going to create an arc kind of above and below. And then I'm going to do the same thing over here. And it creates those 2 intersection points. And then I'm going to create the line through those. So
through that point and through that point. Now where they meet, those two perpendicular bisectors, you can see that they are meeting here. Perpendicular bisector this side. Now you could do the third side, but actually, and it will go through this, so it's okay to do that. I'm going to shortcut this a little bit. This is called the circumcenter. This is the same distance from A as to B because it's on this perpendicular bisector, and it's the same distance to A and to C because it's on this one. So in truth, it's the same distance to all three vertices. So if I now go get my circle tool, and I pick that center point, and if I pick one of the vertices, it goes through all three of them. Very nice, isn't it? Let's do an incenter now. An incenter is found by finding the angle bisectors. And one way to create an angle bisector, oops, I did that wrong, is to the tech tools aren't working for me. Here is to create a circle. And then what you do from here is you keep your compass the same. So let me pull out my compass. And let me get that measurement right so that my compass has that same length. There we go. And if I go up to this location here, and using that same compass length, I make an arc there. And then run down here and make an arc again. Where those two meet is our angle bisector. So if I click on this and click on this, there's our first angle bisector. Now again, what you can do is you can run down to another vertice. I'm going to make this a little bit smaller here. And again, we can make our arc there to get our two intersection points. And then we run up to this guy, and again we make an arc in this position, and now run down here. Let me snap it into place. It's not snapping here. Hold on a second. I am disconnected here. Let's get her to the right place. Come on, there we go. Snapped into place. And now let's make the arc here, and I'm able to create a new line. There she is. And that is another angle bisector. Now, the nice thing is those two angle bisectors, they meet at our point right here. This line, this angle bisector is equidistant to this side as it is to this side. This angle bisector is equal to this side and this side, so that point is, because it's on both, is equidistant to all three sides. Now one of the tricks to that is that we need the perpendicular line to get the distance to the side. We want to think that it's just simply, and maybe I'll show you that it's not, but there's part of us that wants to think that we can just create a circle. Let's try that again. My circle wasn't at the right location. We want to create a circle like this, but you can see that it doesn't touch each side once. So what we do is to create our perpendicular line. Out comes my compass again. I'm going to snap it in at point E there. And let me shorten up my compass a little bit here. Something like this. Maybe I'll do it longer. All right, so then we swing our compass, and what we do is we intersect once here, and then once over here. Now, using those locations, we swing an arc down into this location, and we swing an arc on this location. And sure enough, guess what? We create a line that is centered here at our incenter, and we want it to go through that intersection. Now, where do they meet? Where that meets this side, by doing this construction, this was the perpendicular through a point not on the line. That is our perfect radius, E to this location here. So if I pick up my circle tool, select my center, select that spot, and bam, the Incircle is created. So I thought I'd try it using the tech tools. It's actually a little bit more awkward than the actual tools, but you can follow me through this. It should be no problem.